All right, so today we're going deep on variables, like really understanding variables in programming. You with me?
Absolutely. Sounds like a plan.
Perfect. We've got this article here, kind of like our roadmap for today. It explains variables in programming super clearly, too. Like it gets right to the point, no fluff.
Straight to the good stuff,
All
yeah.
right, so think of it this way. Variables are like containers. In your kitchen, you've got your flour, sugar, spices.
Each in its place, right?
Exactly.
hmm
Well, in programming, it's the same. Variables hold the information your program needs. They're like ingredients for your code.
That's a great way to think about it. Helps to visualize it.
So why are these variables so important? They seem pretty basic, like little storage bins for data.
Yeah, they are like the memory of a program. Think about it. Every time you use a program, type in your username, click a button.
Variables are storing all that.
Exactly. They hold on to that information. But it's not GDST passive storage. You can also use them to manipulate data.
Oh, okay. Like how?
Well, think of a game. Like when your score goes up. That's variables at work.
So they're keeping track of my progress.
Right. They're updating and tracking everything. It's all happening behind the scenes. But that's not all.
There's more.
Oh, yeah. Variables are also about reusability.
Okay, I've heard that word before. What does that mean in this context?
Imagine this. You're writing code, and you need to use the same value like 100 times, instead of typing it out over and over.
You use a variable?
Bingo. You store that value in a variable once, CA, and then just reference it wherever you need it, change it once, and it updates everywhere. Super efficient.
Wow, so it's a huge time saver.
Absolutely. Plus, it makes your code so much easier to read.
That's always a plus, especially when you're working with a team.
Oh, for sure. Imagine trying to read code where everything's just labeled like A, B, C.
Could be a nightmare. So good variable names are important.
Super important. It keeps things clear and easy to understand for everyone. Okay, so we know WHY variables are important, but how do we actually start using them?
Yeah. Where do we begin?
Well, first you have to declare a variable.
Declare. What does that even mean?
Okay, imagine you need to store something on a shelf, right? You need to make sure there's space for it. Declaring a variable is like reserving that space. You're telling the program, hey, I'm going to need a spot for this later.
Okay, I'm with you so far. So how do we actually do that?
It depends on what programming language you're using. Like in Java, you might say something like int age. That sets aside space for an integer, a whole number, and we're calling it age.
Okay. What about Python? Is it the same?
Python is a bit different, a bit more direct. You declare AD, assign a value at the same time. So you can say name Alice.
Whoa. Okay. So that created the variable. I put something in it.
Yep. It created a variable called name and put the string Alice right into it. So in Java, you reserve the space, and in the Python, you reserve the space, and put the ingredient in all at once.
That's pretty cool. So different languages have different ways of doing things.
For sure. But the basic idea is the same. You're setting up a variable to hold some information.
Okay, so we've declared our variable. Now what?
Well, now you need to assign it a value. This is where you actually put the ingredient into the container.
Okay, so that's assigning. Gotcha. But is there anything we need to be careful of here? Like, can we put any kind of information into any variable?
Good question. That brings us to data types, which are super important. They're like categories for your ingredients. You've got your integers for whole numbers, floats for numbers with decimals.
Wait, hold on. Integers, floats. What are those?
Okay, let's break it down. Integers, those are your whole numbers, like if you're counting something. The number of clicks in a game, for example.
Oh, okay. Makes sense.
And floats.
Floats are for when you need more precision.
Hmm.
Numbers with decimals. Like if you're calculating averages or dealing with financial stuff.
So integers are whole numbers, floats are for decimals.
Yeah.
Got it. What else is there?
You've also got characters, which are basically single letters, numbers, or symbols. So like anything you can type on a keyboard.
Exactly. And then there are strings, which are like chains of those characters. So words, sentences, whole paragraphs, anything you can type.
So characters are the individual letters and strings are the words.
You got it. And then there's one more important data type, Booleans.
Booleans. That's a new one. What are those?
Think of them like a simple on-off switch. They can be either true or false.
Interesting. So they're used for things that are either one way or the other.
Exactly.
Wow.
They're really useful for decision-making in your code. Okay, so we've got integers, floats, characters, strings, A&D, Booleans. That's a lot of data types.
Yeah, my brain is starting to get full. So let me see if I've got this straight. We declare our variable. Then we assign it a value, making sure it's the right data type. What else is there?
Well, now we need to think about where these variables actually live within our code. This is where the concept of variable scope comes in. But before we jump into that, what are your initial thoughts on these data types? Any of them stand out to you?
Honestly, they all seem pretty important. I can already see how each one would be useful in different situations. But yeah, I'm definitely curious about this variable scope thing. It sounds kind of mysterious. Like, where do these variables hang out? What are the rules?
Uh-huh. Good questions. We'll get into all of that in just a bit. But first,
Yeah, this variable scope thing, it sounds kind of like a set of rules. Like, where are these variables allowed to hang out in our code?
that's a great way to think about it. Scope basically defines the visibility zone of a variable, like where in your code it can be seen and used.
Okay, I think I get it. So it's not like they can just roam free and do whatever they want.
Exactly. Imagine a big program with different sections, like rooms in a house.
Yeah.
Some variables, they might be accessible throughout the entire house,
Mm.
like they have free reign. But others, they might only be available in specific rooms.
Okay, so some variables are like house guests that can go anywhere,
Uh-huh. I like that.
and others are more like, say, the kitchen utensils. They only work in their designated space.
Perfect analogy. Now we're cooking. So let's talk about the two main types of scope. We've got local and global.
Local and global
Well,
are
local variable, right?
Yeah.
That's declared inside a function.
inside a function.
Yep. And it's only accessible within that specific function. Like your kitchen utensil example,
Yeah.
only the chefs in that kitchen can use it.
Makes sense. So it's like a secret recipe that's only available in that one spot.
Exactly. It's contained. Now, global variables, on the other hand,
Okay, global variables.
those are declared outside of any function. So
Yeah.
they're accessible from anywhere in the program.
Oh, so they're like the house guests with full access. They can go wherever they want.
Precisely. It's like a shared resource that the entire program can use. But, there's a catch.
There's always a catch. What is it?
Well, global variables can be super convenient, sure, but they can sometimes lead to problems.
Uh-oh. What kind of problems?
Imagine you've got a big program, right? And multiple parts of your code are all trying to modify the same global variable. It can get really messy.
Oh, I see. Like it's hard to keep track of who's changing what.
Exactly. It can create all sorts of unexpected behavior,
Hmm.
especially in those larger programs.
So using global variables is kind of like having too many cooks in the kitchen.
Haha, exactly.
Uh,
It's a recipe for disaster.
Mm.
So, as a general rule,
uh,
it's best to use local variables whenever you can. It helps keep your code organized and minimizes the risk of things going wrong. Keeps those cooks from bumping into each other.
okay, local variables good, global variables.
Mm,
Use with caution. Got it. So scope is all about keeping things tidy and organized within our code. But there's another aspect of organization that we haven't talked about yet.
right. Naming conventions.
Yeah. We touched on this a little bit before, like giving variables good names so your code is readable. But are there, like, actual rules?
They're definitely best practices. The goal is to make your code as self-explanatory as possible. Think about it. If you were reading a recipe and all the ingredients were just labeled ingredient 1, ingredient 2,
It would be impossible to follow.
right, you'd have no idea what was what. So with variables, the same idea applies.
So a good variable name actually tells you what the variable represents. Instead of just using X or Y, we'd use something more descriptive.
Exactly. Like instead of X, you could use player score or item price. Makes it instantly clear what's going on.
Yeah, it's like labeling your kitchen containers clearly so you don't accidentally grab salt when you need sugar.
Haha, exactly. Clear labels, clear code, everyone's happy. And when you've got longer variable names, there are conventions to make them even easier to read, like camel case and snake case.
Oh, yeah. Camel case is where you capitalize the first letter of each word after the first, like player name. And snake case uses underscores to separate words, like player score.
Exactly. And honestly, the choice between those is often just personal preference or like whatever your team usually does.
Okay, so it's mostly about consistency and making sure everyone's on the same page.
That's the key. Now, there's one more thing we need to talk about when it comes to naming variables.
Okay, what's that?
Reserved keywords.
Reserved keywords. I've heard that term before, but I don't really know what it means.
Okay, so reserved keywords are specific words that you can't use for variable names.
Why not? What's so special about them?
The programming language itself uses them for other things. So if you try to use one as a variable name, it'll get confused.
That makes sense. Can you give me an example of a reserved keyword?
Sure. The word if is a common one. A lot of programming languages use it for conditional statements. Those determine which blocks of code should be executed based on certain conditions.
Oh, okay. So if I tried to name a variable if, the program would think I was trying to write one of those conditional statements.
Exactly. It's like trying to use the same word for two different things. It just creates confusion. So it's best to avoid using reserved keywords for your variable names.
Okay, got it. So we've covered a lot of ground here. We talked about declaring variables, assigning them values, making sure they have the right data type, and then keeping them organized with the right scope. Oh, and giving them clear, meaningful names, of course. All while avoiding those tricky, reserved keywords. Whew, it's a lot to remember. But it seems like it all comes down to keeping our code clean and functional, right?
You nailed it. It's all about writing code that is easy to understand, maintain, and debug. And now, to really solidify all of this,
Yeah.
let's look at a real-world example.
Perfect. Because sometimes all this theory can get a bit abstract. It helps to see how it all works in practice. So what kind of example are we going to look at?
Our source uses the classic example of calculating the area of a rectangle.
The area of a rectangle. Sounds pretty simple.
It is, but it perfectly illustrates how variables work in a program. So for this calculation, we'd need three variables: length, width, and area.
Okay, I'm following. So first we'd assign values to length and
Yeah.
width, right? Like the actual measurements of our rectangle.
Exactly. And then we use those variables in a formula. Area equals length multiplied by width.
Okay, pretty straightforward. So we plug in the numbers, do the calculation, and damn, we've got the area. But I'm guessing there's more to it than that. What's the bigger picture here?
Well, this example really highlights the power of variables in making your code reusable.
Reusable? How so?
Instead of hard-coding specific numbers into that formula, we can just change the values of length and width, and the calculation will still work. It's like a dynamic formula that adapts to any rectangle we throw at it.
Oh, wow, yeah. That's much more efficient than having to rewrite the whole thing every time.
Exactly. And that's just one small example of how variables can make your code more flexible and dynamic.
So even a simple calculation like this can reveal a lot about the power of variables. Pretty cool.
It is right. So what are your thoughts on this example? Anything that stands out to you?
You know what's really cool about that example?
What's that?
Even though it's so simple, like just calculating the area of a rectangle,
Right.
it shows us so much about how variables actually work, even in, much bigger, more complex programs.
Yeah, absolutely. It's like a little microcosm of the whole concept. And I think it also highlights how variables aren't JST placeholders for data.
They're more than that.
Way more. They're the
Mhm.
tools that let us build these really dynamic and interactive programs. The stuff that really makes software come alive. I mean,
Yeah.
think about it. Variables are the foundation for all sorts of complex algorithms and data structures.
It's like those simple wooden blocks we used to play with as kids, right?
Yeah.
They seemed so basic. But you could use them to build towers, castles, whole imaginary worlds.
Exactly. And variables give us that same power, but in the digital world. So, yeah, embrace the power of variables. Experiment with them. Don't be afraid to, really push the boundaries of what you can create.
It's pretty amazing to think that something as fundamental as a variable can unlock so much creative potential.
It is.
It's like, I don't know, learning the alphabet. Once you know the letters, you can start forming words, sentences, eventually write entire novels.
Perfect analogy.
Yeah.
And mastering variables. That's like learning the alphabet of programming. It's a crucial step on your journey because they really are the building blocks for everything that follows.
Well, I think we've covered just about every aspect of variables today, from declaring them to assigning values, understanding data types, and even diving into scope and naming conventions. Phew, we've done a lot.
We have. It's been a deep dive for sure.
It's been so fascinating. I feel like I have a much better understanding of these little building blocks of programming now. So as we wrap things up, what's the one key takeaway you want our listeners to walk away with? The thing that'll really stick with them?
I'd say the most important thing is to remember that variables are the key to creating dynamic and interactive programs.
Dynamic and interactive.
Right. They give you the power to manipulate data, make decisions, and ultimately bring your ideas to life in code. It's all about what you want to create.
It is inspiring to think about all the possibilities that open up once you truly understand how to work with variables. They really are the foundation of everything, from simple scripts to those super complex applications that power our world.
Couldn't have said it better myself. And the best part,
The best part.
the journey of learning and mastering programming. It's
Yes.
full of these exciting moments. You'll be amazed at what you can accomplish.
Well, it's been an absolute pleasure diving into the world of variables with you today.
But that's
Thanks for guiding us through all the ins and outs.
my pleasure. It's always fun to demystify these fundamental concepts and, share the joy of programming.
And to all our listeners out there, keep those programming brains buzzing. Who knows what incredible things you'll build once you've mastered the art of variables. Until next time, happy coding, everyone.
See you the next deep dive.